Alright, so in today's video, we're going to take a look at what's inside a computer. More specifically, we're going to talk about what is on the motherboard and how does it all work. Now, this is a motherboard, and every computer has one. Motherboards come in different sizes. The ATX versions, they're usually used for bigger computers, while the ITX versions are usually used for smaller computers like, laptops and cell phones, stuff like that. Now, for a computer to be a computer, the motherboard needs three things. The three main components it needs is a CPU, RAM, and mass storage. Most computers that have a display also need a GPU, also known as a graphics processing unit. But we're going to go over the three main parts today because in order for a computer to be a computer, it doesn't necessarily need a graphics processing unit. Now, mass storage, also known as SSD or solid state drive, is the long-term storage of a computer. That's where data is stored when you shut off the computer. No electricity is being powered to your machine. The computer also needs RAM, also known as random access memory. The hard drive moves data to the random access memory when using a program. The CPU will interpret the program from the RAM. A CPU is probably the most important part of the motherboard, also known as a central processing unit. A lot of people refer to this part of the motherboard as the brains of the computer. And we're going to take a look a little deeper into the CPU and how it functions. Now, you could think of the CPU, or the central processing unit, as a man in a box. A man in a box that is really good at math. Now, this man's purpose in this box is to help people with math, right? With their math problems. And the only problem is that we can't communicate with him. He can't communicate with us. Because there's no windows, no doors, we can't get into the box. So we have to figure out a way that he could understand us and we can understand him. We may not have a formal way to communicate with this guy in the box, but we do have light bulbs or light switches. Now, each light bulb has an on and off switch. The on corresponds to a 1 and the off corresponds to a 0. So anytime we flick one of our light bulbs on, he is also able to see what light bulb is on or off. Now, in order for the man to understand our requests, he has a code book of sorts to make sense of what each of the ones and zeros mean in certain patterns. This code book is often referred to as machine language. Each machine is able to understand these ones and zeros, and if put in a certain pattern, we're able to communicate with the machine and request and get information. Now, the man in the box is not alone. He actually handles a team that basically optimizes the getting and receiving of information, also known as a core. Now, when requests come into the CPU, you could think of someone clicking a button outside of that box, and that's called a clock. So anytime the button is pressed, a request is made, code is drawn up, and then that code is distributed into the general purpose registers that are handled by the core, or the part of the CPU that optimizes data. So if there are many requests going in all at once, the man in the box doesn't have to do it all himself, and he's able to do more than one thing because he has people helping him. Now, there are constantly requests going in and out of the CPU, anywhere from like a mouse click or keyboard, anything really that needs information continuously draws that information from the CPU. Modern CPUs are measured by two things: clock speed and cores. Clock speed is measured in gigahertz, which represents the frequency at which a CPU's core can execute instructions. It indicates how many instructions a core can process in a given amount of time. Higher clock speeds enable faster execution of instructions, resulting in quicker computation. So let's go back to the man-in-the-box analogy for a second, also known as the CPU, right? So the man-in-the-box, he could only understand the machine language of the ones and zeros that, the on and off switch represent. Now, each light bulb represents a bit, and there's 8 bits in a byte. So the more cores a CPU has, the faster it could actually process the bits. So if a computer had, let's say, a single core, it might be only able to process 32 bits, whereas let's say another computer had dual core or two cores, it might have 64 bits and could process a lot more data all at once. A 32-bit computer can hold up to 34 billion bits at a single time. However, data is typically denoted in groups of 8 bits, which are known as bytes. Therefore, a 32-bit CPU can be used to process about 4 billion bytes, or 4 gigabytes, at any given time. The biggest companies right now for CPUs are Intel and AMD. Alright, so just to quickly summarize, basically, for a computer to be a computer, you need a CPU, RAM, and mass storage. If you have all 3 of those, technically, it's a computer. There's even more simplified versions of a motherboard called a Raspberry Pi, which is like the motherboard. It's RAM, it's the CPU, and mass storage. Very simple. Doesn't have a GPU or anything. Very basic, but those are like the main components you guys need. You guys need to kind of have a computer. Now, the CPU is the brains of the operation. If you guys remember the man-in-the-box analogy, it's basically the thing that tells the other parts what to do. The CPU's whole job is basically to take requests, right? Those mouse clicks, those keyboard clicks, requests from servers, basically take that information and translate that into zeros and ones into the machine language that it understands in order to process your request. Now, there are tons of other like features and little things that I could like discuss. It gets quite complicated, but for this video, I kind of want to keep it broad and give everybody a general understanding of what a computer is and basically how it functions on the most basic level. Alright guys, so that's it. If you guys found this useful, drop a comment or a like, or give me a follow, and I'll see you guys in the next one.